Hello students, in this video we're going to begin chapter 7 on hypothesis testing, and if there's any time left remaining in the video we'll do one or two examples from section 7.3. So keep in mind that we are skipping section 7.2 and that for the homework in section 7.1 you can find the answers to the questions either by reading the section or by watching the first several minutes of this video. Okay, so let's go and get started. So every hypothesis test we will do in this course will have a null hypothesis represented by the symbol H sub 0 or H0 and an alternative hypothesis represented by the symbol H sub A or HA. We will focus on performing hypothesis tests on one population parameter in this chapter. Okay, so like I said, we're skipping section 7.2. So beginning in section 7.3, we will perform hypothesis tests on the population mean mu. In section 7.4, we will perform hypothesis tests on the population proportion p. And then in section 7.5, we will perform hypothesis tests on the population standard deviation sigma. When setting up the null and alternative hypotheses in a hypothesis test, we must select the appropriate symbol for the population parameter we are testing. Okay, whether it is the mean, proportion, or standard deviation. Okay, so it's worth mentioning that once we determine the parameter that we're testing, right, whether it's the mean, proportion, or standard deviation, right, that symbol is going to be used in both the null and alternative hypotheses. Okay, so the population parameter will be the same in both the null and alternative hypotheses. So keep that in mind. Okay, so the null hypothesis H0 will always contain one of the three following symbols, right? So either a less than or equal to symbol, a greater than or equal to symbol, or an equal to symbol. Okay, so the symbol we use in the null hypothesis, right, will determine the symbol we use in the alternative hypothesis. So in other words, when setting up these two hypotheses in our hypothesis test, right, we will always choose one of these three symbols first in the alternative hypothesis, and then based on that, we will choose the correct symbol in the null hypothesis. Okay, so the alternative hypothesis HA will always contain one of the three following symbols, right? Either a less than, greater than, or not equal to. The symbols we use in the null hypothesis will depend on the wording used in the problem. So in the null and alternative hypotheses. But remember, we always select the appropriate symbol in the alternative hypothesis first, and then followed by one of these three symbols in the null hypothesis. Okay, so if the symbol used in the alternative hypothesis is the greater than symbol, okay, the opposite of that would be the less than or equal to symbol. And that's what gets used in the null hypothesis. Okay, whenever the greater than symbol is used in the alternative. Okay, likewise, if the symbol used in the alternative hypothesis is less than, right, then we use the greater than or equal to symbol in the null hypothesis. And then lastly, if the symbol used in the alternative hypothesis is not equal to, then we will use the equal to symbol in the null hypothesis. Okay, so in other words, the symbols we use in the null and alternative hypotheses will be opposites or complements. So for the hypothesis tests we do in this chapter and in the next chapter, we will do the 5 following steps. Okay, so in step 1, we're going to state the null and alternative hypotheses by using the correct symbols. Okay, in step 2, we're going to state the level of significance of the problem, okay, represented by the symbol alpha. Okay, this is the Greek letter alpha. Okay, if the level of significance is not given, right, we're going to use alpha equal to 0.05. In step 3, we're going to calculate the p-value of the test using StatRange, right? Or we're going to find the value of the standardized test statistic by using the appropriate formula. Okay, but for most of the questions in chapter 7, we're going to use the p-value approach, okay, rather than the classical approach. Okay, but there might be 1 or 2 questions in section 7.5, right, where in step 3 we're going to find the standardized test statistic rather than the p-value. Okay, we'll talk about that when we do the examples in section 7.5. All right, step 4, we're going to decide whether to reject the null hypothesis based on the p-value. So if the p-value is less than the significance level, we reject the null hypothesis. Okay, likewise, if the p-value is greater than or equal to the significance level, we do not reject the null hypothesis. And then lastly, in step 5, we state a conclusion that summarizes our results by saying there is sufficient evidence or there is insufficient evidence. Okay, so let's go and take a look at an example from section 7.2. All right, and this is problem 2 from the homework. And it says, an oceanographer claims that the mean dive duration of a North Atlantic right whale is 11.7 minutes. A random sample of 36 dive durations has a mean of 12.2 minutes and a standard deviation of 2.2 minutes. Okay, so at the significance level alpha equal to 0.10, is there enough evidence to reject the oceanographer's claim? And we're going to complete parts A through D below, and then we're going to assume that the population of these dive times for all these North Atlantic right whales is normally distributed. Okay, so we're first going to identify the claim and state the null and alternative hypotheses. Okay, so the parameter that we're testing here, right, is the population mean. Okay. Right, so it says in the first sentence, an oceanographer claimed that the mean dive duration of these whales is 11.7 minutes. Okay, so the key word there is mean. Okay, meaning that the symbol we use is the one for the population mean, which is the Greek letter mu. So that's going to be the same for both the null and alternative hypotheses. Okay. So the claim here is that the mean dive duration is 11.7. Okay, it doesn't say greater than or less than, right? It simply says is. Okay, so that's going to translate to equal to. Okay, so remember, right, when we set up the alternative hypothesis, right, we're going to use one of these three symbols, right? Greater than, less than, not equal to. Okay, so the way that this problem is worded, okay, right, when it says the mean dive duration is, right, this number of minutes, okay, that means in the null hypothesis, right, we're going to say the population mean mu is equal to 11.7. Okay, the problem it had said is greater than 11.7 or less than 11.7, right, then you would choose the appropriate symbol in the alternative. Okay, either the less than symbol or the greater than symbol. Okay, but in this case, right, this tells us how to set up the null hypothesis. Okay, but in most cases, we set up the alternative hypothesis. All right, so because we use the equal to symbol in the null hypothesis, right, then the symbol we use in the alternative is not equal to, right, the complement, the opposite, so the opposite of equal to, or the complement of equal to, is not equal to. Okay, so keep that in mind. All right, so in the alternative hypothesis, right, it's not equal to, and then type in 11.7. Okay, and notice that this number is the same for both hypotheses. Okay, so the claim is actually in the null hypothesis. Okay, but in most cases, it'll be the alternative. Okay. Okay, this says use technology to find the p-value, so we're going to use StatCrunch to do this. Okay, so we're going to type in some of this information into StatCrunch. So let's go to StatCrunch, stat, then tstats, and we're dealing with only one sample of data. All right, we don't have the actual data, but we have a summary, so we're going to select summary. Okay, and according to the problem, the sample mean was 12.2 with a standard deviation of 2.2. Okay, and our sample size was 36. Okay. So the null hypothesis is that the population mean is equal to 11.7. Okay. And then the alternative is that it's not equal to 11.7. Okay. And that's all we need, right? So we enter the summary of the data. So the sample mean, standard deviation of the sample size. Okay. Enter the hypothesized population mean, which is 11.7. Okay, and then select the appropriate symbols in the null and alternative hypotheses. Okay, so for the hypothesis test, we're going to select this button. Okay, we selected this button in the previous chapter for confidence intervals, but for hypothesis tests, leave this button selected. Okay, and we can also include a p-value plot, but that's optional. Okay, so this is a hypothesis test for the population mean, and then it gives you the sample data, okay, degrees of freedom, the standardized test statistic called the t-stat, and then this is the p-value that we're looking for. Okay, we're going to round that to 2 decimal places, so our p-value rounded to 2 decimal places is 0.18. Okay, so it does want the, sorry, I failed to mention this right here. So it does want the standardized test statistic. So it does want this. So the 2 decimal places is 1.36. Okay, but we do want the p-value eventually. So if you read the last part here, right, find the standardized test statistic, right, that's what you would input as your answer. Okay, and then we input the p-value. Okay, but it wants it rounded to 3 decimal places, which is 0.181. Okay, in this case, it wants both the test statistic and the p-value. Okay, so based on our p-value and our significance level, right, so you compare the p-value to the significance level, and remember, if the p-value is less than the significance level, you reject the null hypothesis. If it's greater than or equal to the significance level, right, do not reject the null hypothesis. Okay, so clearly the p-value of 0.181 is larger than our significance level of 0.10. Okay, so we are going to fail to reject, or do not reject, the null hypothesis because the p-value, okay, is greater than alpha, which is equal to 0.10. Okay, so hopefully that's clear. Okay, and then we're going to interpret the decision in the context of the original claim that was given in the problem. Okay, so we're going to complete the sentence in part D of the problem, okay, to interpret the decision that we just made. Okay, so keep in mind that we did not reject the null hypothesis because the p-value was larger than the significance level, right? So in other words, our p-value, which was 0.181, okay, is greater than our significance level of alpha equal to 0.10. Okay, so sometimes there's more than one way to state the conclusion. Okay, so basically we're in step 5, right? We did the other 4 parts already. Okay, so one way to state the conclusion is that, therefore, there is insufficient evidence to reject the claim that the mean dive time for all North Atlantic right whales is equal to 11.7 minutes. Okay, that's one way to say it. Okay, in other words, so the claim was given in the null hypothesis, saying that the mean dive time was equal to 11.7 minutes. Okay, another way to state this claim is that, or state the conclusion is that, therefore, there is sufficient evidence to support the claim, okay, that the mean dive time for all North Atlantic right whales is equal to 11.7 minutes. So if you read these carefully, they're actually saying the same thing, right? In the first statement, we're saying there's insufficient evidence to reject the claim, okay, which is kind of like saying there is sufficient evidence to support the claim. Okay, so they're both saying the same thing. Let's see. So there is. Let's go this way. So there is not enough evidence at the 10% level of significance, right? So convert that into a percentage to reject the claim that the mean dive duration of North Atlantic right whales is equal to, right? Since that's the symbol used in the claim, which is equal to 11.7 minutes. So let's see if that works. Okay, yeah, so that does work. Right, and there may have been more than one way to state this, so keep that in mind. I'm not really sure, but you could also say there is enough evidence at the 10% level of significance, okay, to support the claim that the mean dive time, dive duration of a North Atlantic right whale is equal to 11.7 minutes. So there might have been an equivalent way that you could have answered this question. Okay, so always keep that in mind, right? There might be more than one way that you can complete the interpretation or the conclusion to a hypothesis test. Right, but essentially the two ways of stating the conclusion are essentially equivalent. Okay, in the next video we'll do one more example from section 7.3.